Back in 2015, NASA dropped an absolute bombshell that took over global headlines. We had found a planet sitting right smack in the habitable zone, orbiting a star that looked incredibly like our own sun. Honestly, it felt like the universe had finally handed us a mirror. But as we're going to see in this explainer, the mystery of Kepler 452b actually holds one of the greatest plot twists in modern astronomy. With such wildly familiar characteristics, the immediate question on literally everyone's mind was, wait, did we just find Earth 2.0? Had humanity actually stumbled onto some cosmic paradise, primed and ready for oceans, continents, and maybe even life? The hype around a second Earth was absolutely colossal. I mean, the stakes just couldn't be higher. And that initial enthusiasm was completely justified. Kepler 452b orbits a star emitting this familiar, golden light, very much like the sunshine we're used to. Plus, it sits right in that magical band of its solar system known as the habitable zone, the Goldilocks sweet spot. Not so hot that everything boils off into space, and not so cold that it's a frozen wasteland. Liquid water could actually exist there. It really looked like the perfect setup. But hold on a second. Before we go packing our bags for this new world, we've got to talk about how we actually find these things, because the mechanics are pretty mind-bending. Hunting for planets way outside our solar system is a near impossible task. Why? Well, planets don't emit their own light. They're small, they're cold, and they get completely, totally washed out by the blinding glare of their host stars. Think about it like this. Trying to see an exoplanet directly through a telescope is literally like trying to spot a single grain of sand orbiting a lighthouse thousands of miles away. The beam from the lighthouse just absolutely blinds you. So, how on earth did NASA pull this off? The solution was just pure space engineering genius. Back in 2009, the Kepler Space Telescope launched. Now, it wasn't there to snap pretty photos of planets. Its job was to stare, unblinking, at over 150,000 stars using the transit method. The logic is brilliantly simple. If a planet crosses exactly between its star and our telescope, it casts a tiny shadow, blocking a microscopic sliver of the star's light. But a single dip in brightness? That doesn't prove a thing. It could just be a glitch in the camera. The real magic is in finding a repeating pattern. When that exact same dimming happens over and over at the exact same interval, boom, you've got the unmistakable signature of an orbiting planet. Now, what is truly staggering here is this number. When I say the dip in light is tiny, I mean the planet is often blocking less than 1/100% of the star's brightness. Yet our instruments were somehow sensitive enough to capture this near-invisible shadow from a star located way out in the constellation Cygnus. And that is exactly how Kepler 452b was proven to exist. And this is exactly where the story takes a massive turn. When we think of habitable worlds, we're naturally so fixated on the planet itself. But here's the thing, the fate of any planet is entirely dictated by its star. The star controls the climate, the atmosphere, the whole shebang. And when scientists finally stopped looking at just Kepler 452b and shifted their focus to the star illuminating it, they didn't just see a distant world. They saw a terrifying vision of our own future. So let's compare them. The star, Kepler 452, is a yellow dwarf, just like our sun. But take a look at the age. Our sun is roughly 4.6 billion years old. Kepler's star? It's 6 billion years old. That's 1.5 billion years older than our sun, and it packs about 10% more mass. Put simply, we aren't looking at a young Earth. We're looking at a dramatically older, aged version of our very own solar system. So why does that matter? Well, as stars like the sun age, they slowly get brighter and pump out way more energy. Billions of years ago, this planet probably received the exact same amount of cozy heat that Earth gets today. It might have been an absolute paradise back then. But today, with its star cranking out so much more energy, Kepler 452b might be suffering from a massive runaway greenhouse effect. Paradise might be totally gone. And it's basically showing us exactly what is going to happen to our Earth a billion years from now when our own sun ages and heats up. Knowing that the aging star completely changes the game, let's pivot back to the planet itself. I mean, despite the older star, there is still a chance the planet held on, right? So what do we actually concretely know about this distant world? First off, it's big. It falls into the super-Earth category, meaning its radius is about 60% larger than ours. Now, a quick heads up, don't let the name fool you. Super-Earth does not mean it's an identical, utopian version of Earth. It's strictly a measurement of size. But the models do show it has a very high chance of being a rocky planet. If it is rocky, the gravity there would be intense. Walking around on the surface, your body would feel significantly heavier. But that extra gravity is actually a huge bonus because it could help the planet tightly grip a much denser atmosphere for billions of years, creating a heavy-duty protective shield. And check out this detail because I think it's absolutely fascinating. 385 days. That's how many Earth days it takes for Kepler 452b to make one full trip around its star. 385 days. That is incredibly close to our own 365-day year. That means if this planet has a tilt and experiences seasons, the length of its spring, summer, fall, and winter would feel astoundingly familiar to us. Which leads us straight to the ultimate philosophical question of our analysis today. Could life actually exist out there? We've got a rocky world with a year almost perfectly matching ours, but it's orbiting this older, much hotter star. Did life somehow manage to survive all that stellar evolution? Here's the harsh reality. Just sitting in the habitable zone isn't enough, especially when your star is actively heating up. A planet needs a whole complex system of gears turning perfectly together. It needs an atmosphere of the exact right thickness to act as a thermostat. It absolutely has to have a strong magnetic field to deflect the brutal stellar winds that are constantly trying to blast that atmosphere away into space. And it needs continuous geological activity, think volcanoes and shifting tectonic plates, just to recycle vital chemical nutrients. And if you think real estate, just location, location, location is everything, look at our own cosmic neighbors. Mars used to be in a highly favorable spot, but it lost a huge chunk of its atmosphere and turned into a frozen, barren desert. Venus, on the other hand, basically the exact same size as Earth, but its climate was completely wrecked by an extreme greenhouse effect, turning the whole place into a toxic hellscape. The habitable zone is really just step one of the recipe for life. It is definitely not a guarantee. Because Kepler 452b is so unimaginably far away, our current tech has limits. We can't exactly zoom in and snap a photo of its surface. So, scientists are working with three main hypotheses for what it looks like today. Scenario 1, it could still be a lush world, hanging on with deep oceans and vast continents sculpted by its heavy gravity. Scenario 2, thanks to that older star, it might have completely boiled dry, leaving behind a superheated rocky desert. Or Scenario 3, it held on to so much gas that it's just an incredibly dense, cloudy sphere. But, don't let that bit of uncertainty take away from the sheer, mind-blowing magnitude of this discovery. Take a second and really think about what humanity just pulled off. Everything we've unpacked in this explainer, the size of the planet, the age of its star, the exact length of its year, its possible apocalyptic fate, we figured literally all of that out by analyzing microscopic flickers of light from a single pinpoint over 1,000 light years away. And we did it without ever leaving our own solar system. No sci-fi starships required. Just relentless curiosity, math, science, and light. And that brings me to a final thought I want to leave you with. Kepler 452b is utterly fascinating. Not just because it might be a second Earth, but because it is quite literally a cosmic time machine. Looking at it is like peering into a mirror and seeing the wrinkles of our own future staring back at us. As we watch this distant world struggle against the rising heat of its aging star, you really can't help but wonder, what does Kepler 452b reveal about the final fate of our own planet? When our sun eventually ages and the cosmic clock ticks forward, are we just going to be the next mystery that some distant civilization tries to decipher in the flickering light?